Hello everybody, this is Mr. Arocena. Today's lesson we're going to be talking about elements and compounds and what makes them up. Alright, let's get to it. So, elements and compounds you guys have probably studied in earlier science classes, as early as Science 9 and possibly Science 8 depending on who your teacher was. So today will probably be just mostly a quick review. Alright. So, what makes up elements and compounds? Well, we talked about this a little bit the previous day. Or maybe I'm confusing this with my other chemistry class. Anyways, elements are made up of atoms. And atoms, by definition, are the smallest possible piece of matter that contains its own chemical properties. So they're not the smallest piece of matter, because we know that atoms are made up of subatomic particles, and then those subatomic particles are actually made up of even more things, but we won't get into that right now. So the atom is the smallest possible piece of matter that has its own chemical property. We cannot see this with the naked eye, but they can form larger structures called molecules, which are still really small, and we can't see those with the naked eye. These not individual molecules, but we can see the things that they make up. This picture here, it was taken with, I believe, this is a sheet of carbon. And those are individual carbon molecules. Sorry, carbon atoms. Individual carbon atoms. Okay, so we've got microscope technology now that can see individual atoms. It's kind of strange, but that's what this carbon sheet looks like. Okay. Now, elements. They are a type of matter, a type of pure substance that consists of only one type of atom. Okay, so they can consist of many atoms, but they're characterized by being only one type of atom. So, for example, if this is a carbon atom, a sample of carbon will contain the exact same atom. So, if this is carbon, this is a carbon atom. Okay, all samples of carbon contain this atom. Okay, if it contains a different atom, it is not carbon. Okay. Now, some elements can exist as molecules of atoms. These are what we would call like the best example would be the diatomic elements. So this is a diatomic molecule of hydrogen. Okay. The other diatomic elements are nitrogen, oxygen, fluorine, chlorine, iodine, and bromine. Okay. Those are the other diatomic molecules. So those molecules tend to exist as partners with others. Sulfur and phosphorus are also polyatomic molecules, or I guess, yeah, polyatomic molecules, but they're not diatomic. Depending on their form, they're different. Okay. Now, similar to elements are the compounds, which are also pure substances, but they're characterized by the fact that a compound is a combination of elements. So there are multiple elements that make up a compound. So unlike elements, where the elements are made up of a single type of atom, a compound is made up of several types of atoms. Right. And in previous science classes, we broke these into two broad categories of compounds: ionic compounds, which are made of ions, and covalent compounds, which are made of molecules. Now, what differentiates them is that an ion, these are charged atoms. So what this means is that they have either an excess of electrons, or they have a lack of electrons. Okay, excess of electrons leads to a negative charge, and a lack of electrons leads to a positive charge. So this example down here is, let's say the green balls are positive. Since they have a positive charge, they will attract anything that is negative, which for argument's sake will make the blue balls negative. So they don't actually exist as full-on individual molecules, because anytime you have a negative charge, it will attract a positive charge. Every time you have a positive charge, it will attract a negative charge. So this is what's called an ionic lattice, if you remember that word from Science 9 and Science 10. Basically, all the ions will continue making this lattice network until they run out of ions. A covalent compound, by contrast, is made of molecules. So here's an example of a water molecule, and it would have, if you had a sample of water, it would contain molecules of water like so, and they would just be floating around. They would not have any no real attraction between them. So the attraction between these molecules is weak, so weak attraction. Okay, so it's unlike with the ionic lattice here, where every positive attracted a negative and every negative attracted a positive. In a covalent compound, the molecules aren't too attracted to each other. Okay, and we'll discuss this in a lot more detail in a future unit. Okay. Now compounds, because they are made of multiple elements, you actually can break compounds down into their individual elements. This is usually done with a chemical process. You can't do this with a physical process because, as we discussed earlier in the semester, physical processes don't change the chemical composition of the particular compound. In order to change the compound, you have to run it through a chemical process. So for example, here's water. And water can be broken down into hydrogen and oxygen, but this requires a chemical process. Chemical process needed. Okay, so we can't just take a knife and cut the hydrogens off of the oxygen. We need something a little more than just a knife. Okay. By contrast, elements cannot be broken via chemical processes because, as we mentioned earlier today, elements are the smallest, or I guess they're made up of a single type of atom, and the atom is the part that retains its identity. If we break down the atom, then it's no longer the element, it just becomes electrons, protons, and neutrons. Okay. Interestingly enough, physics methods can be used to break these down. So I'll make a note here that nuclear methods can be used. So nuclear methods can break elements. For those of you from physics last semester, you'll know this because we discussed it in the nuclear energy unit. Okay. Now, interestingly, despite compounds being made of many different elements, the compounds will usually have properties that are quite different, or quite different from the elements that make them up. Take, for example, water. Water is composed of hydrogen, which is a very combustible gas, and oddly enough, water is not very combustible despite having 2 hydrogen elements in it. Okay. Similarly, sodium and chlorine are both very dangerous elements. Sodium is a soft metal that, when it comes into contact with water, will explode. Well, not really explode, it generates a lot of hydrogen gas and heat, and then if there's enough heat, it'll cause the hydrogen gas that it generated to explode. And then chlorine, so this is sodium, and then this is chlorine. Chlorine is a highly toxic gas where if you were to breathe it in, it would, if I remember correctly, it would effectively eat away at your lungs from the inside out. Combined, they will create table salt, which is a very mundane substance. I mean, the worst you could do is increase your chances of getting diabetes, I think. So, albeit I guess table salt in that respect is dangerous, but it's not nearly as dangerous as exploding metal that comes into contact, or metal that can cause water to explode, or chlorine gas which can eat you from the inside out. Okay, sodium chloride is, for the most part, in moderation, is quite tasty, or at least makes food taste better, depending on who you ask. Alright, so yeah, so compounds have properties that differ from their component elements, and when you combine elements, don't expect them to have this. Don't expect the compound to have similar properties to the elements you used. Okay. Now, as we discussed in the previous lesson, both elements and compounds are considered pure substances. Okay. They are not considered, or compounds are not mixtures. This is a common mistake. Okay. Not mixtures. Okay. So anytime where the chemical composition is fixed, so this is chemical composition, anytime the chemical composition is fixed, we consider that material a substance, or I guess more precisely a pure substance. If the chemical composition is not fixed, then the material is what we call a mixture. Okay, and then we had two types of mixtures from the previous lesson, remember? We had homogeneous mixtures. I should change this to chemical composition. So we had homogeneous mixtures and heterogeneous mixtures. And that kind of depended on, I guess, the composition of the mixture in relation to itself. So if its composition was fixed relative to itself, it was homogeneous. If the composition of the mixture was not fixed relative to itself, it would be heterogeneous. Okay. Now, as far as chemistry goes, to help us identify elements, we tend to defer to chemical symbols and formulas to help us represent our pure substances. So here's an example of the periodic table, or one of the elements in the periodic table, and most periodic tables share these properties, where in the corner here is usually listed the atomic number of the element. Okay, this corresponds to also the proton number of the element, and as long as the element is neutral, this would be also the electron number in neutral element. Okay, these here are the most common ion charges. Common ion charge. Sometimes there's multiple ion charges. This here is the symbol, which is universal throughout the world. So if you give a chemist in Japan this symbol, they will hopefully know what it is. They should know what it is. Okay. This is the name of the element name, and they'll usually also have this number, which is the average atomic mass. Right. In previous classes they might have just told you it's the atomic mass, but we'll discuss why we call it the average atomic mass here. This number here, this particular periodic table showed it, but most at the high school level do not. But this is the electron arrangement, and we will discuss this in more detail later. Whoops, not mean to go too far back. Yeah, so the electron arrangement, we will discuss this later. Not every periodic table shows this, but this particular one did. Alright. Right. Now, one last thing to review are the states of matter. So in probably Science 7 or something like that, you guys probably discussed the states of matter, and there were 3 states of matter. We know them. There's actually more, but we discussed 3 main ones. Solids, where the atoms and molecules are arranged in a very rigid structure. So most solids are very closed like this, where the particles, the atoms or molecules, do not have much room to move around. So they can basically just sit there and vibrate in place. Okay, so these just vibrate in place. I think it's the kinetic molecular theory, which you were probably shown in Science 8. Liquids have a little bit more structure. They are connected, but they're not rigid. So a liquid has a lot more freedom to just slide around amongst the other elements. They're still connected, but they are not rigid. So these individual molecules or atoms have the freedom to just slide around. Okay, they have some, I guess, some translational motion. And gases, they are completely disconnected from each other. So they just zip around aimlessly like that. And they're very far apart, and they just zip around. They have a lot. They're very energetic particles. Okay, so that's what the gas is. Okay, now interestingly enough, there are certain points in the how you can arrange these structures. Like for example, with a solid, you can actually attain a solid structure with enough pressure. Usually though, the transition from one state to the next is dependent on energy. So going from one state to another depends on absorbing or releasing energy. Okay, so for example, if I want to go from a solid to a liquid, I need to absorb heat or absorb energy. But going from a liquid to a solid is the opposite. This is a release of energy. I know it's kind of strange to think that getting colder is a release of energy, but it is true. So going from one state to or matter to another, you either have to absorb or release energy. Okay. Then we'll discuss. You guys will just work on this some more later today. Okay. All right. Okay. So it's a quick review of atoms and compounds and elements and the states of matter. Your assignment for today then will be as follows. Do read those pages, complete the assignment, and if you have any questions, feel free to come find me when I return. Right.